All right, here we go, page 6. Last page before your test. Here's my two systems, and they say use it by using the elimination method, which means I need to line up my x's and my y's, my equal signs and my constants. I'm looking for a zero pair. And it doesn't matter here what I'm going to cancel out. I'll choose my y's. I'm going to multiply this equation by a -3 and this equation by a +2. That's going to give me 10x plus 6y is equal to 30. And -6x minus 6y is going to be equal to -12. Here's my zero pair with my 6's. So when I go and add them together, I get 4x's is equal to 18, which is curious. It doesn't work out evenly. Let me double check my math. 2 times 5 is 10, 2 times 3 is 6, 2 times 15 is 30, 3 times 2 is 6, 3 times 2 is 6, 3 times 4 is 12. When I line up, 10 minus 6 is 4, and 30 minus 12 is 18. All right, folks, we got ourselves a fraction. X is going to be equal to 9/2. When I go to substitute 9/2 back into either equation, I'm totally picking this one because my 2's will cancel out. So 2 times my value for x plus 2y is equal to 4. So I'm going to go ahead and stick 9/2 in there. This is the same as 2 over 1, so those cancel out. So my math is not quite so hard. 9 plus 2y is equal to 4. Subtract 9. Subtract 9. 2y is equal to 4 minus 9. Sounds like -5. Divide by 2. Divide by 2. Y is equal to -5/2. Therefore, my solution is going to be equal to the xy ordered pair that makes both equations true. 9/2 and -5/2. All right, moving on to the next one. I'm going to go ahead and multiply this equation by a -1. My original equation stays the same. For my top, I have -x² minus 3x plus y is equal to 11. But now this equation is going to be positive 12x², positive 3x, negative y, and of course 0 is neither positive nor negative. That's going to give me 11x². Check it out. I've got 2 zero pairs is equal to 11. Divide by 11. Divide by 11. x² is equal to 1. Take the square root. X is equal to plus or minus 1. So what that means is I need to put 1 and -1 both into one of my equations to solve. I gotta be honest with you, I like this equation best. 12x² plus 3x. I'm going to add y to each side, and that'll help me when I'm solving for y. 12 times my value plus 3 times my x value is equal to y. First I'll put 1 in there. 12 times 1 is 12 plus 3. Therefore y is 15. Choose my second value for y. 12 times my value squared plus 3 times my value is equal to y. I'm going to put -1 in here, -1 in here. -1 squared is positive 1. times 12 is 12 plus this is going to be negative 3, that's a change, is equal to y. 12 plus negative 3 is going to be positive 9 is equal to y. Therefore, my ordered pairs are going to be a 1 and a negative 1. I have a positive 9 and I have a 15. All right, last system. Here we go. They say use elimination. Looks like I'm going to have my y's cancel out because I have my x squareds and these two x's here. Canceling x's is not going to be an option. So I'm going to multiply this top equation by negative 1. That's going to give me positive x squareds, positive y's, minus 1 is equal to 0. My second equation stays the same. 2x squareds minus 10x minus 2y minus 4 is equal to 0. Looks like I'm going to have to multiply everything by negative 2. That makes this 2x squared. That makes this positive 2y. And that makes this negative 2. When I add them together, 4x squareds, here's these y's that cancel out, minus 10x minus 6 is equal to 0. All right, it's a quadratic. I'm going to take out my greatest common factor first. Divide by 2, divide by 2, divide by 2. So my quadratic is 2x squareds minus 5x's minus 3 is equal to 0. So I'll go ahead and factor. I'm going to use guess and check because I think I have a feeling how this is going to work out. This has to be 2x and x. This has to be negative 3. So it's either plus and minus or minus and plus, 1 and 3, or 3 and 1. I want negative 5, so I have to get negative 6 as a product. And I have to have a positive 1 to add to it. So 2x plus 1 is equal to 0. X is equal to, subtract 1 from each side, divide by 2. X minus 3 is equal to 0. X is equal to 3. Now I have to figure out what y is equal to. And I got to be honest with you, I'm coming back to this equation, and I'm going to use that in the graphing calculator. That equation is negative x squared plus 1 is equal to y. See how I added y to each side? So I can go ahead and enter that into my graphing calculator. I'm going to use my negative x squared plus 1 is equal to y. When I go to my table of values, I'm looking for the output for x is negative 1/2 and 3. So with 3, I got 8. Over 3, y is equal to 8. This one's a problem because it's a 1/2. So I'm going to use my table set. It's the second function on window. I'm going to ask my table to go up by halves. Now I can see negative 1/2. There it is. Negative 1/2 and 0.75 is the same as 3/4. So I'll leave that in fraction form. Okay, here's the cumulative review. You ready? All right, we have f of x is equal to ax squared plus 3. What is the equation? of the axis of symmetry. When I had, look here and see my symmetry, I had the vertex of positive 2 and 3. So my axis of symmetry is going to be the vertical line with an undefined slope that goes through that point in the vertex, that x coordinate. And A has nothing to do with it. We don't need to worry about A at all. All right, number 2, if this is my format of my quadratic equation, I see the intercepts. X is going to be equal to 3, and x is going to be equal to negative 5. Again, this A is going to mean that the graph opens down, but that doesn't change where it hits the x-axis. So when I look for my solutions, positive 3 and negative 5, that's not right. That's not right. That's not right. So I look good with B. All right, what is the y-intercept of the graph? So my y-intercept for an equation in standard function or in standard form is always going to be that constant. And there's only one, so that's got to go. And I need to write it as the y-intercept. The y-intercept is when x is equal to 0. So that's going to be the right answer. What are the coordinates of the vertex of the graph? Now this is tricky. They didn't give it to me in vertex form, but that's easy for me to fix. Because negative 2 times x minus 1 squared, I'm going to subtract 5 from each side. This 5 needs to be over here in order for me to see the vertex. So my vertex is going to be positive 1, because that's naturally negative, and negative 5, because that's true to sign. So positive 1 and negative 5 is over here at A, and we're good to go. Which is the complete, there's that word, complete factorization of 4x cubed minus 64x. Don't get freaked out by all the x's. What you want to do first is take out whatever g, c, f that you have. So this 4x cubed, I can take out a 4 and I can take out an x. And that's going to leave me with x squared minus 64 divided by 4 is going to be 16. So that's going to be 16. Guess what? This is the difference of two perfect squares, and we'll factor into x plus 4 and x minus 4. And 4x, remember, don't forget about him out front. So it looks like letter C is our choice. This one matches, but it's not factored completely. This is not the right answer. Neither is this. And this would be if they were perfect cubes, but they're not. All right, a quadratic function with a discriminant of negative 32 has how many x-intercepts? None of them are real. So we're going to cross off all those reals. And imaginary numbers always come in pairs. So I know it has to be imaginary. All right. If f of x is equal to 3x minus 2 and g of x is equal to x squared, then g of f of x. So you're putting f inside of g. So my g function is x squared. So I'm going to tuck f inside of that. So then when I go to simplify that, that's going to be 9x squared. Because keep in mind, that's the same as this. And then foiling. 3x times 3x is 9x squared. Then I have 3x times negative 2 is minus 6x for both my outer and my inner product. And then plus 4. So I have 9x squared. This combines to negative 12x's. And there we go. Alright, our next problem has to do with i's. And like we've talked about before, I don't know who is going to ever have this many i's. But I do know that 1917 divided by 4 is going to give me 479 groups of 4 i's that are all going to equal 1. This last one that I have left over is 0.25. That represents 1 leftover I. 1 leftover I is equal to I. That's going to be multiplied. Now we're going to take care of this one. 2454 divided by 4. That gives me 613 groups of 1. And then a 0.5 left over. 2 i's is I times I, which is going to be negative 1. So when I multiply those together, I get negative I, which is answer B. So make sure you study all of your notes. Make sure you go over past quizzes and tests. Don't let the same mistakes hurt you twice. See you soon.